Hello and welcome back, Algebra 2 class, and specifically, hello, Caitlin, because otherwise you'll complain and vote for Burger instead of me. We're going to try a couple new things today. First of all, we're going to try playing with some of this background music that you might be able to hear right now. We'll see how that goes. And second, I'm going to try to focus on not talking when I'm facing away from the mic. So hopefully that'll improve the sound quality of this recording a little bit. So our lesson for today that we briefly started talking about in class is on logarithmic functions and equations. And our objectives for this set of videos are going to be to convert between exponential and logarithmic form. We'll go into some more detail on what that means, and to evaluate logarithmic expressions. So right at the end of class today, we had this equation, this exponential equation on the board, 2 to the x equals 8. And as we talked about it, we decided that 2 to the x equals 8 is really saying, well, 2 raised to what power gives us 8? And we were able to kind of figure out some quick thinking that, well, 2 raised to the third power, or 2 cubed, equals 8. In other words, x in this case must be 3. Now, as it turns out, this kind of equation, this exponential equation where we don't know the exponent, is common enough and useful enough. There's actually another set of equations that are really connected to it, based entirely around, or based largely around, finding that exponent. Though that other kind of equation is called logarithmic equations. So a logarithm is the exponent to which a specified base is raised to obtain a given value. A little more specifically, we can convert between an exponential equation and a logarithmic equation using this form here. So starting with an exponential equation where we have b to the x equals a, right? B is our base, a is our given value that we're trying to find, or that we're trying to get equal to on the other side. We can convert that to logarithmic form by saying, well, log base b, that's how that's read, of a equals x. Remember, x was our exponent before. It's still the value of the exponent, but now we have isolated it. That's the benefit of these logarithmic equations, is that x, which is presumably the piece we don't know in a lot of these problems, is now alone and easier to find. So logarithms help us find out what that unknown exponent is. So we go back to that equation we had, 2 to the x equals 8, and we try to write it as a logarithmic equation. So here's our exponential equation again. We're going to write it as a logarithmic equation. Well, we know our base, b, is 2, right? Because we can look at our exponential part of this and say that our base is 2. So that means that in logarithmic form, we're going to have log base 2. That b over here will be 2. A, from the right side of the equation, is 8. So we're going to be evaluating log base 2 of 8. And then it's equal to the exponent, which in this case was x. Now, we were able to already figure out that an x in this problem must be 3, because 2 to the third equals 8. So what that means is that the answer to this logarithm, right, if we evaluate the logarithm log base 2 of 8, the solution is also 3, right, because the exponents have to match up there.